Hello friends, welcome to this new video. Here we discuss a very important improper integration of 1 divided by x minus a whole raised to n between the limit a to b. Integration of 1 divided by x minus a whole raised to n between the limit a to b. Now you can see that if we take n less than equal to 0, that means, for example, if we take n is equal to minus 1, then 1 divided by x minus a whole raised to minus 1, this will be x minus a and it is easily integrable terms. Integration of x minus a equal to x minus a whole square divided by 2. Hence, it is a proper integral for n less than equal to 0. This is integral is proper. Integral is proper. Now, if n less than 0, so if we consider n greater than 0, if n greater than 0, we have this integral is improper. It becomes improper integral. It is improper for n greater than 0, and a is the point of infinite discontinuity. A is the point of infinite discontinuity. Now friend, it has a left end having infinite discontinuity. Therefore, we integrate this a to b 1 divided by x minus a raised to n into dx. We write it as limit lambda tends to 0 and a plus lambda, limit from positive x minus a whole raised to minus n into dx. So its integration will be x minus a whole raised to minus n plus 1 divided by minus n plus 1 between the limit a plus lambda to b. These are the bounds, and limit is lambda tends to 0 from right side. Okay, or we write it as limit x lambda tends to 0 from right. At upper limit the constant value is 1 minus n, and at upper limit this is 1 divided by b minus a whole raised to n minus 1. When we take it in the denominator, this will be minus become plus, and this plus become minus, n minus 1 minus. At lower limit, when we put here a plus lambda, a and minus a will be cancelled, and we have 1 divided by lambda raised to n minus 1. Okay. Now here already we have taken n is greater than 0. Now if n is less than 1, that means n is equal to 1 by 2, suppose positive. So n is equal to 1 by 2, then we have this 1 by 2 minus 1, that is minus 1 by 2, and minus 1 by 2 will becomes here 1 divided by lambda raised to minus 1 by 2. This will be lambda raised to 1 by 2, and as lambda tends to 0, this will becomes 0, and we have then this value is equal to 1 divided by 1 minus n into 1 divided by b minus a whole raised to n minus 1. Now when n is greater than 1, that means n equal to 2, suppose n is equal to 2, so this is 1 divided by lambda, and 1 divided by lambda will be infinity, and hence this value diverges for n greater than 1. So we have finite value only for which n is less than 1. Now here we have consider now n is equal to 1. When we consider n is equal to 1, integration a to b 1 divided by x minus a into dx equal to limit lambda tends to 0 from right, integration of a plus lambda to b 1 divided by x minus a into dx equal to limit lambda tends to 0 from right, integration of this is log of x minus a between the limit a plus lambda to b equal to limit lambda tends to 0 from right, log of b minus a, log of b minus a minus log of a plus lambda minus a, lambda tends to 0. Okay, so this will be limit lambda tends to 0 from right, log of b minus a minus log of a cancel log of lambda, and in the between 0 to 1 log is infinity, so this is an infinite value. Okay friends, then look the values of n. For n greater than 1 and n equal to 1, the integral is diverges. Also the integral is proper, means it is a proper integral for n less than equal to 0, and for n less than 1 the integral has definite finite value 1 divided by n into 1 divided by b minus a raised to n minus 1. Hence we can say that this integral is converges only for n less than 1 and diverges for n greater than equal to 1. So this is an important integral which gives us the exact values of n for which the integral is convergence. Thank you friend, thank you for watching.